Let's move on to the next question. Now here we have to prove this particular statement as shown here. If you observe, the left hand side has a lot of terms, whereas on the right side we have just sin theta plus cos theta. So now here we see another technique, that is all the terms in the left side are to be converted in terms of sin theta and cos theta, and at the end we simplify the expression. So like the first term is cos theta upon 1 minus tan theta can be written as sin theta upon cos theta, isn't it? Plus the second term is sin theta upon 1 minus cot can be written as cos upon sin. So therefore, on simplifying, this cos theta will go up and the denominator will be simplified as below. So it is cos theta upon cos theta minus sin theta plus, the numerator will become cos square because cos and cos will multiply, and in the second term also the numerator sin will get multiplied with the sin and denominator will be sin theta minus cos theta. Now if you observe both the numerators, you see we have cos theta minus sin theta and sin theta minus cos theta. So these two terms differ only with the sign, and by sign it's SIGN sign. So changing the sign of the second term, we will make the second term as negative, thereby we can switch the denominator terms and write them as cos theta minus sin theta, and here we will have sin square theta, and in the first term denominator is same, that is cos theta minus sin theta, and the numerator is also cos square theta. So since the denominator is same, now we can merge both the fractions. Numerator will have cos square theta minus sin square theta, and the denominator will be cos theta minus sin theta. So if you observe the numerator, it is of the form a square minus b square, so that can be clearly factorized as cos theta plus sin theta multiplied by cos theta into cos theta minus sin theta. So that means we can cancel out a factor of cos theta minus sin theta from numerator as well as denominator. So therefore, on cancelling the factor of cos theta minus sin theta, what we are left with is nothing but the RHS. So that's the way we prove this particular statement. Let's go ahead and see a different variety of the question which asks us to eliminate theta from the following relations. X is equal to a sec theta and y is equal to b tan theta. Now the meaning of this question, that is eliminate theta, what it means is we have to form or we have to arrive at a relation in all the other variables or the arbitrary constants mentioned in the given information. So if we see, apart from theta we have x and y as well as a and b. So the job is to form some relation between these four quantities in which theta will not be present. So that's the meaning of eliminate theta. Now to eliminate theta, let us look at the terms in which theta is present. So here we have sec theta and tan theta. Let's ask the question, what is the relation between sec theta and tan theta? So if you remember, we have sec square theta minus tan square theta is equal to 1, right? So that means if we can write sec theta and tan theta in terms of x, y, a and b in whichever way possible, by substitution we would have done the job. And it is clear that if you bring a on the left side, then x upon a will be nothing but sec theta, and similarly if you bring b also on the left side of second equation, y upon b will be nothing but tan theta. So merely substituting the values of sec and tan in the term shown here, we can write sec square theta is nothing but x upon a the whole square minus y upon b the whole square is equal to 1. So if you want, we can write the square. So x square upon a square minus y square upon b square is equal to 1. So here we have obtained one relation in which theta is not present. So we have effectively eliminated theta.